the first example at the 1.5 meter from the banks, estimate the flow rate using the measured data from table 13.2. Given this equation to find the flow velocity from the rotation rate of the current meter. So from equation table 13.2 is this from this. So this one we focus on just the distance, the 1.5 meter from the bank. Okay, from this they measure the depth is about 0.345, and this is a point that they record the velocity. With the current meter, there is 15 round per 100 seconds, so we can estimate the rotation speed, revolution per second, and we can convert to velocity, flow velocity 0.146 meter per second. Okay, so come back to our calculation. So for the first, we used mid-section method. Okay, so we focus on this section 1.5. so next we can take the average of the width from the left and the right here, 1.2 and 1.5, take the average, and time the depth 0.345, so the depth 0.345, and we can take the average about 0.466. so this is area like this. Area of this is in area of this area of from the mid section method, and we time the area with the velocity, so we got this number 0.068 cubic meter per second. So the next method, we use the average section method. Okay, so we have to find the velocity at the 1.5 meter and 3 meter is the same velocity, and we take average from two sections. So this is one, we take average from this section and this section, so we got 1.46. The next we take the average of the depth, two sections, got 0.34959, and we find the area is equal to the width times the depth is 1524. so this area is like this, and it's in yellow, so it means this area, this part is, for the average section, this area is like this. It's overlap about half of the section, so this area for the average section, and we can find the flow rate is area time velocity is about 1.077. And from this they can write the number here, that is the 0.07 from the average section and 0.068 from mid section. Okay, the next example is at another point at the section 11.7 from the bank. Do the same. The first is the mid section method. Okay, from this we go to this somewhere here, at 11.7. so in that section there are three velocity. We measure that at the depth 0.41 and 0.69 meter. Total depth is 2.1, and so we have the three velocity at this point. Okay, for the mid section we take the width from the left and right to get 0.9. so this one we can get like this one. Okay, 0.9. so these are the lengths, three lengths, and we measure the difference between the distance through distance and got 0.9, and take average, we got 0.9 meter. And for the next, for velocity we convert from point. This one is the 0.9 is a mean revolution per minute. We can convert to 0.693 meter per second. This way we got the 0.69593 meter per second. So we do the same for another 2 points, and we can take the average based on this weighting factor. So we get the average velocity is 0.663. For the area we can take the average from the width and time the depth, get the 1.9 square meter, and time the velocity we got 1.261 meter. And for the average section between section 11.1, 11.7 and 12.6, so we use the right width, and we take the average of velocity from 2 sections and take the depth from 2 sections, and depth times the width got the area 1.87. so this one is from average section, so we got this area for average section, and we time the area with the velocity we got 1.204 cubic meter per second. And next we can write the number here. For average section we got 1.2, and for the mid section we got 1.261 cubic meter per second. And if we can do for all the section, we can make a summation about total flow on this stream is about 5.97 cubic meter per second. For another method, mid section is about 6 cubic meter per second. So it's not much different between two methods.